All right, guys, so in this video, I'm going to go through the elimination method on these example problems. So again, with elimination method, you want to get it so your y's will eliminate. That's going to make your life a lot easier if you can do that, because if I eliminate one of the x's, that's not going to help me because I will have still either an x or an x squared left over. So in order to make them opposite. So in this case, if we look, here's my y's, they're lined up. And again, you want to make sure everything's lined up nice and neatly and orderly. They're not going to cancel out if they're both positive. So what we're going to do is you can either multiply it by a -1 or just subtract everything. It's the same thing. So whether you multiply by -1 to get them to be opposites and then add them together, or you just start right away by subtracting them, those y's will go away. And then we're left with 0 equals -4x squared minus 24x minus 32. Okay. From here, you can solve by any method. Now, I look at all these numbers. I notice they're all divisible by 4. So I'm going to factor a 4 out, or actually I'm going to divide them all by 4. I'm going to do a -4 because that's what they're all divisible by. Okay, and now I get to this point, x squared plus 6x plus 8. That's easy enough for me to factor. I can find factors of 8 that add to 6 real easily. They're 4 and 2. And then since this is a 1 as my leading coefficient, I know I can simply factor it to x plus 4 and x plus 2. Now, again, if you didn't realize that, if you didn't divide out by -4, go ahead and use your quadratic formula. Label ABC, plug it in. You're going to get the same answers as me, I promise. So if you do factor, you will solve each one. You're going to get a -4 over here, and you'll get a -2 on the other side. Now, just like with substitution, in this case, I do have to plug them back in. And it doesn't matter which one you plug it into. I'm going to plug it into the top one. I'm going to take this equation here. Oops. And I'm going to do one at a time. So if I start with x equals -4, and I plug a -4 in, just be careful how you put those into your calculator. Okay, I would type that in exactly as I see it, and I would end up with a -2 for this one. So I know this ordered pair comes out to -4, -2. And then I'm going to do the exact same thing, but this time I'm going to plug in a -2 into the exact same equation. And again, just be careful how you put it in because we do have signs here. And when you put that in your calculator, you're going to end up with -2 again. So this ordered pair is going to be -2, -2. And those would be my two solutions, -4, -2, and -2, -2. Okay. So number 31. Now with 31, when I write this out, I'm going to make sure I line up things carefully. So the first equation is y plus 2x equals -14. So I'm going to take the second equation and make sure things line up underneath where they should. So a -x squared, I have nothing on top to line it up with, so that's okay. A -y, I'm going to line it up with the y on the top. And then I have a -6x that I'm going to line up with the 2x underneath it, and then equals 11. Now when I look at this, I have everything lined up nice and neatly, and I notice right away these y's are going to cancel out, and we love when that happens. Okay, add everything else down. So I got -x squared minus 4x equals -3. Then I want to get one side to equal 0 so I can solve this. I'm going to move the x squared and the 4x. Now, most people would move that -3, and that's fine. You can. I just like to always have my x squareds be positive. okay? And from here, I would try to factor, but I can't. There's no factors of -3 that would add to a +4, okay? So in that case, we're gonna have to do a little bit of work with our discriminant and our quadratic formula. Okay, so my discriminant, remember that's your b squared minus 4ac. Okay. So a is 1, b is 4, c is -3. Put that in your calculator, and you're going to find out that it comes out to be a 28. From here, I'm going to go through and finish solving my quadratic formula. Okay, so negative of b plus or minus the square root of my discriminant all over 2 times a. Okay, and again, I'll fill in all those values I know. B is 4, the discriminant is 28, a is 1. And then from here, we're going to work on simplifying and reducing that. So -4 plus or minus, I'm going to do the first bottom first. 2 times 1 is 2. Now the square root of 28, I can reduce that. Square root of 28 splits to the square root of 4 times the square root of 7, and the square root of 4 I know is 2. So I have 2 radical 7. And then I notice all those whole numbers are divisible by 2, and if I divide them all by 2, I have -2 plus or minus square root of 7. Those are my x's. Not the prettiest of x's, but they're my x's, and I have to deal with them. So we are going to take, I'm going to take the top equation here, y plus 2x equals -14, just because it's smaller. Okay, and I'm going to plug this in one at a time. Okay, so I'm going to start. And actually, even before I do that, I could choose to get this y by itself and look at it in this format. Completely up to you. However, if you have your y already by itself, once you plug in your x, simplifying is going to make it a lot easier. So actually, let's use this one. So I'm going to start with the positive square root of 7. Okay, so y equals -2 times -2 plus square root of 7. Now to simplify all of this, we would distribute. We get 4 minus 2 radical 7 minus 14. Combine your like terms, you have -10 minus 2 radical 7. So when we put this whole thing together, one ordered pair is -2 plus radical 7 and -10 minus 2 radical 7. Again, an ugly looking ordered pair, but it is what it is. That is the actual value for that part. Then we're going to move myself over here. Then we're going to do the exact same thing, but with the subtraction. So when it's x equals -2 minus square root of 7. Okay, now what you should have picked up on is you're just going to be changing signs here. Oops. Y equals +4, +2 radical 7 now, and -14. Again, combine your like terms, and we have -10 plus 2 radical 7. And again, when I put those together, oops, I have 2 minus radical 7 and -10 plus 2 radical 7 as my ordered pairs. Okay, again, not the prettiest. And if they don't say anything about rounding your answers or approximating your answers, you do have to give the real ones. But if the directions say approximate or round or a decimal answer, then by all means, you could have used the calculator and gotten the decimal values. So just be aware of what the directions are asking you. Okay. Let me clear out number 30 here. Okay. And let's do 32 now. Okay, so 32, again, I take notice when I rewrite these out, I do want to line them up. So there's no x squared in the second one. So we're going to make sure we line them up because now, again, I notice, beautiful, those are going to cancel, positive y, negative y. So we get 0 equals x squared plus 8x plus 14. Again, I can try and factor this, but there are no factors of 14 that add to 8. So just like we did over here, I'm going to start by finding my discriminant. So b squared minus 4ac. Again, a is 1, b is 8, c is 14. Put that in your calculator, and you end up with an 8. From here, find our x, negative of b plus or minus the square root of the discriminant, all over 2 times a. Again, fill in everything that I know. All right, so this reduces to negative 8 all over 2 plus or minus the square root of 8 is 2 radical 2. Again, I can take the 8, split it to 4 and 2, and we know that 4 is 2. Okay, and just like in 31, I know I can divide all these by 2, so I got negative 4 plus or minus radical 2. So just like we did in the previous problem, we have this happening with the ugly looking radical answer for x, but we deal with it. So we're going to take that bottom equation again. I'm going to change all the signs so that way I have a positive y that I'm plugging in. So we're looking at a negative 4x minus 7. And again, we're going to do one at a time. So if I start with negative 4 plus radical 2, and I plug it into negative 4x minus 7, and then I would distribute, combine like terms, do all that stuff like we did previously. So we get 16 minus 4 radical 2 minus 7, which simplifies to 9 minus 4 radical 2. So again, together we have these two. So that's 1. Then I'm going to do it the same with the second one, where now we're subtracting the radical. And again, we distribute, we still get 16. Now we have a positive 4 radical 2 though. So we have 9 plus 4 radical 2. And we have these two ordered pairs. Okay. Again, not the prettiest, but it is what it is. We set it up, we deal with it. Okay. And our very last one, number 33 over there. So let me clear out 31. Okay, so 33, we have y equals. These line up nicely. Now the problem with this one is the bottom, well, both of them are positive, so it doesn't matter which one we look at. So again, the goal is to get these to cancel. If they're the same sign, they're not going to cancel, but I can subtract them or multiply by a -1, completely up to you, however you want to do that. Now the y's will cancel when you subtract. We get 0 equals negative 5x squared minus 50x minus 120. Okay. So from here, again, if you want to do the quadratic formula, go for it. But I noticed all of these are divisible by 5. So I'm going to divide everything by a -5. That's going to get me 0 equals x squared plus 10x plus 24. And I can actually factor this. Factors of 24 that add to a 10 are 6 and 4. Now that I divide out that -5, I can use the shortcut because x is 1, or x squared is 1. So I have x plus 6, x plus 4, set each one equal to 0. So these are much nicer looking values. I get x equals -6 and x equals -4. And from here, your choice, whichever one you want to plug it into. Again, I like using smaller numbers and positive numbers, so I'm actually going to plug it into the bottom one. You can plug it in wherever you want. And again, you just do one at a time. So if I plug in x equals -6 into that, just again, I can't stress it enough, be careful as you plug it into the calculator. Make sure you have parentheses around things. And when you do that, you are going to simplify. This comes out to be a -4. So this ordered pair is -6, -4. And then again, we're going to do it one more time when x equals -4. Again, I'm just going to plug it right back into that original equation there. Be careful of the signs again, because I do have a negative. Put it in my calculator, and this also comes out to be a -4. So I have the ordered pair -4, -4. And again, you can always use Desmos. You can graph these and check them out, check their intersection points, see if they come out to that. The only bad thing with Desmos is you're not going to get these accurate answers or exact answers like we got in 31 and 32. But you can always change these to decimals and see if they do match.